Thanks a lot. Bonjour à tous. Good morning, everyone. I'm coming from Murcia, Spain, which is this little sunny corner of Europe. So when I decided to come to Montreal, I thought I was escaping the heat, but well, it's been one of the hottest summer in history. So yeah. Instead of cool weather that I imagined that I will find, I found something better, which is warmth of people, but also warmth of the city. So Montreal is a truly diverse city where diversity is inherent and it is on the opposite celebrated. So ça c'est vraiment inspirant. I'm very happy to be here. So as someone working in solar energy, I couldn't help noticing that there is an enormous solar potential to be unlocked. With these long summer days and the heat, you are actually losing photons, guys. So I think we need to stop and reflect all how we can contribute to develop this potential. Because as well as photons, our resources can also be slipped away if we don't create our systems, if we don't design our systems to use them wisely, to capture these resources, to use them wisely, and to circulate them again into the supply chain. So to make sustainability part of the design process from the very start. And here's where we'll go today. So first I will set the stage of solar PV. Then I will go on why sustainability really matters, and we'll look at the European policy tools that are in place for photovoltaics. They are also for another number of products, but I will of course mention one of my research topics, which is photovoltaics. So I will focus these policies onto photovoltaics. So especially eco-design and the new Recyclability Index. And finally, I'll touch on waste management enabled through the WE directive, which I will explain in depth. So let's start with Spain. In August this year, we reached 36 gigawatts of installed capacity of PV. In fact, solar already makes 1/3 of the country's electricity production. And this is great this is thanks to the great radiation conditions, but also to a kind of soft permitting that enables PV to be developed. And this is why Spain is among the PV leaders in PV development and deployment today in Europe. This isn't just happening in Spain. As you can see here, PV capacity is exploding around the world. Here in green dots is the operating PV installations. And it's thanks to the levelized cost of electricity from solar, which is cheaper than the cheapest fossil fuel plants that are new, options that are for new projects. So that's why development of PV is accelerating everywhere. At the global level, China, of course, is the leader, which accounts for 50%, over 50% of but numbers are changing as I speak. So far it's more than half of all PV installed capacity in the world, reaching 1.2 terawatts. These in the figure are the annual capacity there. So 357 gigawatts last year in 2024. So China, US, India, Europe are, of course, growing fast, but the global balance seems to be a little bit shifted towards the east. The future of solar looks bright, but of course it comes with a hidden challenge, which is is the waste that we'll create and is creating. So by 2040, EU alone could reach between 6 to 13 million tons of PV waste. By 2050, this number can climb up to 35 million tons. But the good news is that around 90% here So it's not, I hope it's not too small. Here, maybe 90% of the weight of the PV modules, it's composed by glass, aluminum, and copper, which in principle are easy to recycle, but there is still a fraction that contains in lower weight silicon, tin, silver, so other metals and materials that require more complex processing. The potential is high to recycle, but the economics aren't there yet to recycle these fractions. And recycling is often more expensive than producing a new PV module. So we still lack detailed data on what is inside this remaining 10%, and that is a barrier for sustainability. So to understand how and where are the impacts, we turn usually to life cycle assessments, which are an holistic tool to evaluate the impacts in a life cycle of a product, with side applications, for example, to develop an improvement and improving products, or used as a marketing strategy, or to fulfill with environmental legislation. But the goal of a life cycle assessment, and why is looking at the whole life cycle, is to avoid burden shifting. That is that when we are solving a problem, we are not creating another somewhere else. In the case of recycling, in the LCAs, we do usually system expansion. So to consider, so that is to consider avoided burdens, which mean that those impacts that are safe because we are not producing virgin materials. And that's why we'll just sometimes see negative values in the results. I will show you an example in a minute. These represent actually these negative values represent actually environmental benefits, because we are putting materials back into the supply chain. So here's an example, 2 recycling routes that we examined. These are different impact categories, and we can see that in some of them, there are more negative values than in others, meaning that one is above the other. So the takeaway is that recycling does help reduce the environmental pressure of a product, but design of the product, it is what makes those recycling benefits possible. This is often called design for sustainability. So a reminder that the design state lock in actually environmental benefits at the end of life. What is the EU Commission doing about this? Let's look into policy. You've all heard about European Green Deal. If not, it is the EU's roadmap to reach carbon neutrality by 2050. It has intermediate ambitious targets, such as the 50% reduction of greenhouse gases by 2030, and to include or to have 40% of final energy consumption from renewable energies. So Europe is sending a clear message with these policies, which is that the green transition isn't optional. So it is a growth strategy for us. At the circular economy level, the European Commission has different product policy tools. And I will speak about the 1 and 2 and 3, because the 4 are more specific action plans for example, a solar strategy to include more solar into residential. So I will go more onto the broad policy products, which are basically those that you can see in this graph showing the relative sustainability of the policies. And on one end, we have mandatory tools on the left-hand side, eco-design being one of them, which sets minimum requirements that products that are in the scope of this policy have and must meet when they enter the EU market. Then we have the energy label. You have here similar program called Energy Star in Canada and also in the US that helps consumers to decide and to choose a product based on their power purchase or the affordability. On the voluntary side, on the right-hand side, we have green public procurement for institutions and EU eco-label, which are a system to reward best performers, but they are voluntary. But altogether, these policies shape not only what reaches the market, but how these products are designed. They have an influence on the design of the products. For photovoltaics, the scope of the eco-design and the energy label is broad. So it's covering PV modules, PV inverters, PV systems for all market segments, from residential to utility scale. These are some of the requirements under discussion. For example, durability or quality testing, because where else than in a fabrication you can ensure better the quality of the product. So it also includes all the requirements, such as, for example, design for dismantling, making it easier to separate the products at the end of life, access to repair and replacement parts, and a novelty, which is declaring the carbon footprint of PV modules. For inverters, there is also similar requirements, but not the carbon footprint, for example. To be included in the energy label, the European Commission has asked for the development of a new tool for PV, new for PV, but new for any other product. So there is no product yet with a recyclability index. And it is, the recyclability index, it's meant to be included in the future energy label of PV modules and PV inverters. And it is a scoring system that will measure how easy it is to dismantle and recycle a product at the end of life. The goal is to help the manufacturers, the producers, to design more sustainable products, but also to make recyclability part of the market competition. So, well, notice that this is this is for new products entering into the market. So it is agnostic of what is happening at the end of life. And this is kind of a challenge because we need to account for the methods and the methodologies to extract the materials, but on the other hand, is in the features of the product that the recyclability is possible. It's been a co-creation process from the beginning. It has lasted 1.5 years approximately, with multiple stakeholder meetings to test and to refine the methodology. And we have just delivered the final version to the European Commission and will be published in the website that I've put here, down below. So stay tuned if you're interested. First phase of the recyclability index is the identification of the materials that are inside, because they are not equal. Some materials are critical, some are valuable, some have high environmental impact or benefits when recycled. And we looked at the mass, the hazardousness of the products or the materials. So first was to identify which components really matter and to prioritize them. And we used 4 criteria: mass content, criticality, environmental hazard, and the value in a secondary raw material. So from there, we defined relevant parameters to evaluate the products. And we grouped them, the parameters, into 3 main categories. Service related, which is the information that the manufacturer provides together with the product for disassembly, for the disassembly of the product. Is it diagrams? Are there diagrams included? Protocol, is there a protocol for recycling the product at the end of life? So far, of course, there's very few, for not saying none, that are including this information. But the goal is to make them, to incentivize them to include this information, and they can score points. Then we have dismantling parameters, dismantling related parameters, which account for the effort, the number of steps, the tools that are needed. Are they proprietary tools? Are they mandatory, widely accessible tools? the fastening methods, and then a last one, materials related. So which are the materials inside? Are they hazardous or not? Which are they critical? And how is their separation? Or are they combined and bond so that it's more difficult to separate them? So we ended up with this list with these 3 sets of 10 parameters in total. Although one was eliminated, and I just put it here as an exercise of transparency. Like, yeah, of course, there's been, but this is very recently eliminated in the very last round, because it was considered to have some duplicity with number 8, that it was already requiring the declaration of the level of concentration of hazardous substances. The other one was asking for the presence only, or absence. So each parameter is scored in a scale from 1 to 5, being 1 least recyclable and 5 most recyclable. And the aim is to create a consistent and transparent way to compare products. Number of scoring options, so if we have 5 scoring options from 1 to 5, 1 step at a time, or if we have only 3 scoring options having 1, 3, and 5, depends on the parameter. We have also used weighting, different weighting factors. Sorry, these ones, W. Weighting factors for each parameter that have been assessed and came from consensus from the stakeholders. And against all these parameters, we tested real products. 8 PV module models and 8 PV inverter models were tested at the facilities of the National Renewable Energy Center in Spain. We look at the disassembly time, number of steps, force required to remove the frames and the glass, the lamination of PV modules and inverters dismantling, and using qualitative and quantitative tests. For example, 2 technicians dismantled identical 3 kilowatt inverters, and then it took them 9 steps, mostly with basic tools. We recorded the entire process and their tools that they were using and the parts that were separated. Finally, we came we did this exercise of both calibration and validation of the test. So the calibration is really to see whether these scoring ranges make sense, whether they should be in a numbering scale or in an numeric scale or alphabetic scale. While, for example, the validation, what it was checking is that the reproducibility. That's why we used 2 technicians for each of the dismantling steps. Also checking methodological challenges and define tolerances that they will be used for microsurveillance authorities. This index, if it is implemented in an energy label, it is subject to be surveilled by market authorities. So all this to make sure that the tool, it was practical, it was robust. And this is a chart that shows how real PV modules score against a virtual, having of course 5 points, virtual PV module. And you can see the spread across the different categories, service, material, and dismantling related parameters, illustrating that some products are much better and much more recyclable than others. So now, final part is when the PV modules reach the end of life, they need to be collected, transported to a recycling facility. And in the EU, we have a tool to regulate waste, which is the Waste from Electrical and Electronic Equipment Directive, which is rules that are in place since 2003, though it was recast in 2012, that include PV modules since 2014. And this directive makes producers legally responsible for the collection, treatment, and recycling of waste. How do they do it? Well, it also sets recovery targets, but of course the implementation varies across member states, and we will see it. So how is this work in practice done? Is because we rely on extended producer responsibility. One of the most well-known is PV Cycle that operates in Europe, but I've seen that recently has also activities in the US, in Japan, from last month. And the way this works is very simple. The producers, when they put products in the market, they pay a fee to an APR scheme, to an extended responsibility scheme, which is a producer responsibility organization that takes on the logistics, the compliance reporting, and of course it pays for the operations, the recycling operations. So they say this fee that they are paid is based on the number of products they put on the market, or the tons, the weight they put on the market, the producers. And the PROs, the producer responsibility organizations, collect in a pool this fee to finance the future recycling operations. So in this way, the responsibility is transferred for the waste management, is shifted upstream. The framework is there, but I've recently mapped how it is implemented across the 27 member states. And some member states have robust PV systems, some others they don't. It's also related to the PV capacity installed, so the more PV waste you will have in the future, the more measures and activity you can see in the country. And just showing here that, for example, this fee is not a tax, it's not fixed, so it varies across from a very high one to a very low one in the case of Spain or in Austria here. Also, the WE directive categorizes PV modules under category 4 together with large equipment, fridges, dishwashers, and when reporting and when also evaluating or setting targets, if they are setting targets on category 4, then it gets a bit fuzzy, and you don't really know how many PV modules were, for example, collected in a country. So there are some specific countries, some countries in which a specific EE, so product category, has been brought for PV panels. Spain, France, Germany, Italy have a dedicated category for PV panels. And there is also a variation onto whether this fee is visible in the final invoice or bill for consumers or not. This is where my current work is now ongoing. I'm mapping the recycling capacity, the recovery targets, the recycling rates of the different 27 member states. And by, for example, looking for the PV waste collected, I found many, even if there is Eurostat, which all member states are obliged to report the waste on the different WE categories. It's difficult because of this specific or not specific category for PV modules. I'm also mapping the recycling capacity, as I said, and layering the PV installed capacity for having the scale of the problem in each country. So I'll just finish here with saying that, yeah, PV is blooming, but so PV installation is blooming, but so is PV waste. So we need clear data, we need smarter designs, we need international cooperation, not only intra-EU, but also outside EU, to make these products recycle up to 100% and not to the easy one, which would be to just recover aluminium, glass, and copper. So merci pour votre attention. Thanks for listening, and I'm here to answer any questions. Thank you.